everybody. Welcome to day 4 of the Stand Up for Grain Safety Week. I'm Barb Grove, the Quality Systems Manager for Central Valley Ag and the Vice President of JEEPS, the Grain Elevator and Processing Society. I see some of you are doing it already, but hey, please tell us where you're coming from today and put that out there in the chat so we can see how far we're reaching. Today's event is about bin safety. And so I hope you get a lot from today. Please be engaged and participate in our polls and our chats. If you have any technical issues today, please email ghscpromotions@gmail.com, and Catherine's going to throw that out there in the chat box for you. Our learning session today is brought to you by the Grain Handling Safety Coalition with the assistance of an OSHA Harwood grant and also the generous support of our sponsors. And I want to thank those sponsors for you today, because without their generous support, a lot of this couldn't happen. Thank you to Bartlett Grain, Central State Center for Agriculture, Health and Safety, CoBank, Control Stuffs, Inc., and the National Grain and Feed Association Foundation. Again, thank you so much for your support. Our session today will be recorded and will be available soon at www.standup4grainsafety.org. After today's event, you'll receive a certificate from GHSC for this particular event. But if you'd also like to be recognized for some trainings or some things that you're going to do at your own facilities and participating in the stand-up week itself, please go out and register your participation at standupforgrainsafety.org. Due to the number of people that we have viewing, we have everybody's video and sound off. Kind of helps on the buffering there. But we do want to encourage your participation in the polls and in the chat box. We want to hear from you. Throughout the event, we'll periodically launch polls for you. Your participation in these polls kind of assists in that grant process and those requirements, so we know how we're doing in our training. So thank you very much. And we want to show you how it works. So let's start with a couple of poll questions. Salah, if you could launch those. Tell us how many people are watching together right now. Just click the appropriate box if you're by yourself, if you have other people with you. And then tell us a little bit of what you know about bin safety. While you're answering those poll questions, let's talk a little bit about this exciting session that we have today. So today our trainers are coming to you live from the Asmart Grain Training Center in Bloomington, Illinois. And they're going to not only be presenting to you, giving you their knowledge about bin safety and different aspects of it, but they're also going to be giving live demonstrations. So I'd like to introduce our first presenter today. His name is Dave Newcomb. Dave is retired with over 35 years in fire rescue and EMT services and is the program manager for the Agriculture Rescue Program at the Illinois Fire Service Institute. Dave expanded the grain bin rescue training program at IFSI, including developing a new course for volunteer departments, initiated a large animal rescue program, and assisted in the formation of a technical rescue team while in the fire department. Dave is a pretty popular speaker, and his training in the agriculture rescue, aside from all this training, Dave also farms about 2,200 acres of corn and soybeans. Dave, that doesn't sound like you're a very retired person, but thank you for coming to us today.
Well, good morning and thank you. I appreciate having this opportunity to meet with everyone. And, we're going to start the day off here with what we call Lockout Tagout. And this is a program and a procedure that a lot of folks are probably familiar with, but by the same token, we very much know that this saves lives and it's very simple. So we're going to get started. We got a lot to cover in a short amount of time. And we look forward to this. And like I say, if we get questions along the way, we'll get them taken care of. So here we go. So lockout, tag out, each time, every time. Lockout, tag out saves lives. It can be used at home. It can be used at work. It can be used anywhere and everywhere. It's so basic and it absolutely makes a difference. So it's everybody can do it. So once again, this is my information. So we're going to explain lockout, tag out, when it should be used. We're going to explain the concept of one key for one person. We're going to describe all the basic steps, working through all that. It falls under OSHA 1910-147. It's about protecting our employees. Once again, I always worked under that part that says everybody goes home at the end of the day, and this works. It makes a difference. In this, we also do our written procedures. Once again, information. Everybody needs to understand how the process works, and everybody's on the same page so that when they see this is happening, they all know what's going on. It's affordable. It's very easy to do. It's not big dollars. It could be something as simple as if I didn't have the right thing with me, if I had a heavy duty zip tie and a piece of paper, I can make a lockout tag out. It's something that makes a barrier for something to be turned on. It is mandatory for commercial and non-exempt farmers, and it is a best practice. So once again, it protects us against injury. It protects us against unexpected startups during service and maintenance, or anytime we might be working anywhere near exposed electrical. And it keeps others from turning machines on. How common could it be for us if we're working on something and we have to go make a repair, we shut the machinery off and we go start our process, and if I didn't secure it, how common or how possible is it that someone could walk in there and say, hey, we're supposed to be unloading grain, and start flipping switches, and things happen because it wasn't secured, and then we get in trouble and then somebody gets injured. Lockout, tag out, it controls hazardous injury. It isolates the power sources in that if we got an electrical or pneumatic or anything like that, we shut off the power supply to it. Working in grain, especially, our first goal in lockout tag out is to make the grain static. We don't want things moving. We can use it to de-energize machines using isolation devices. Once again, locks, those are the things that we lock it out so that it can't be moved. And then we also have to take care of the stored and residual energy. And energy is electrical, mechanical, hydraulic, pneumatic. You can see all that. All those different things are forces and that play into the role. A lockout device is lockouts defined as an energy from a system or machine or process which physically locks a system in a safe mode and prevents energy from getting to it. If I disconnect the electricity and I lock it, I then prevent the electricity from energizing that equipment to make it move. And that's what we're looking for. So this is a tag out. Once again, tags. This is our warning device. This tells us why that lock is on there. It's a labeling system. It can say do not operate, or it could be a power cord's locked out or anything. But the whole point is that something can't be accidentally turned back on when somebody's working on something or has their person in a dangerous situation. It also says who did the lockout. We want only authorized employees to perform a lockout tag out. If I've got a person that's his first day on the job and he's just now starting to learn everything, he wouldn't be the authorized person to do the lockout tag out. It would be the seasoned employees, but they're learning it. We're going to train all of our employees. We want everybody on the same page. It's very critical that everybody understands when I see that red and black tag that there's a reason for that. We always use proper locks and tags. And we also have written procedures. We want that so that everybody's on the same page. And every year, sometimes it feels like we're preaching to the choir, but above all, we want to review those procedures every year because now and then we need to make protocol changes if systems change or if we've changed machinery or there's something specialized with that. We want to make sure that everybody's up to speed. Okay. We also work under the auspice that one lock, one key, one person. I have my lock and I have my key. So if I'm locking out, I've secured it, okay? And nobody else can unlock that padlock except me. And the important of that is if I'm in a situation, if I'm in a dangerous situation, or I've locked a piece of equipment out to work on it, only I can re-energize it to put it back into procedure, okay? If I have a multiple person deal, if I'm working, once again, I come from the fire side, I'm the rescuer. So I may have 3 or 4 rescuers working in a situation. If I've got 3 or 4 people working in a bin or around machinery, there's going to be 3 or 4 locks, depending on those people are going to be on that device. It will not get re-energized or reactivated until all of the people are back and accounted for. So I hope this helps make things understand how it's going. But once again, it's 1 lock, 1 person. And if it takes, if it's a dozen, it's a dozen, whatever it takes. That's critical. When is it needed? If we're going to do service or maintenance, when we're working on equipment, every once in a while, machines are machines and they can break down, and they also have to be taken care of. So we want to make sure that we're doing proper maintenance so that everything's working in proper order. That's critical. So when we have to do maintenance, we do lockout, tagout. We shut the machinery off, we lock it out, anything like that. If I had to go in and bypass or remove a guard, say on a belt drive or something on a motor, say I had to adjust belts or something on a drive, lockout, tagout would be used for that, because I have to take the guards off and be able to work on that piece anywhere around that. Okay. Any other safety devices that I have to do that I might have to bypass or go around, lockout, tagout plays a part in that. If I had to put any of my body parts in any part of my body in a position where it can come in contact with pieces that can move or anything like that, lockout, tagout works. Okay. And especially in grain bin entry, if we're going in, we're going to lock out, tag out, because our first goal is to stabilize, make the grain stable, so that machinery cannot accidentally turn on and make grain move and get people into danger. Okay. No lockout, tag out, limited exceptions to not using. We're not going to go into that because we're going to work on this, but it could be as simple as if I had say I had a drill or something working on an extension cord, I can unplug it. And as long as I maintain control of that cord, I've essentially done lockout, tag out. And I dated myself in a program one time when I said, how many of you unplugged the drill when you changed the bit in the end of it? And a student said, I didn't know drills had cords. So, I've once again dated myself. So, and I am sometimes referred to as the poster child for everything you should never do. So that's why I'm in this. So we want to do that. Or if I have something where it cannot accept a lock, once again, something that's got a cord or something, but I can control it. Lockout, tag out each time, every time. We just get right into the habit of, if this has to happen, this is where we go, and this has to be done before we move on any farther. And any employee and every employee, if they see this trying to be short-circuited, has the obligation to each other to call it out and stop the process. Okay. So if we're going to do a lockout, say we're at a process, we've got to go in and change a motor on a system, adjust belts, who knows. We have to identify the energy sources that we're going to lock out. And then we also have to notify all of the people who are affected by this lockout. If we're going to shut down an unloading system in a grain elevator or a processing plant or in a factory where you've got machinery working through like an automation, if I've got to shut part of it down, it's probably going to affect everything downstream from that. So everybody needs to know that this is going to happen. And that way they're all affected, and everybody realizes that from this point forward, they're doing this. And so we're locked out and we're shut down. Number 2, we shut down the machinery. Okay. And we follow our protocols. You notice in the picture on the left, notice how he's getting ready to pull the disconnect and how he's facing away. This is also a critical procedure in that we want to do that, in that if something should flash or arc out of that, your face is protected. So always look away, keep your body turned away from that when you're shutting it off and also turning it back on. We won't do that. And actually in our hands-on, we're going to demonstrate that just a little bit. And then if you look at the slide on the right-hand side, you'll see that they're actually bleeding air pressure off of a tank from a system that's run by air pressure. So they're taking the air pressure off of that to stabilize and lock the machinery out. So once again, why are we looking away? We very much do not want that arc. If it should arc, we don't want to have that to blind us or hurt us. Now we've isolated it. Number 3 is to isolate the energy source, disconnect any all energy sources. Once again, we We can put a chain on something if it's a valve or something that has a wheel. And then also on the right-hand side, you can see we're bleeding pressure, which is releasing stored energy. And the stored energy could be anything like grain in a leg. You know, if a leg gets plugged and you unplug it where it could run backwards, that would be an example of stored energy where things can happen. Here we are once again, mechanical. Things are under tension, hydraulic under pressure, pneumatic under air pressure, and then just plain gravity pulling down on the items. But these are all stored energy examples that we need to be cautious of and be aware of. Other examples, battery backups, you know, springs, struts and all that, like on vehicles and all that, when you're doing things like that, capacitors that can hold electricity, flywheels just from their momentum and all that, gravity, hydraulics. And once again, all these items are energy, can have stored energy. So we want to release it, you know, dissipate it, and then once again, grounding, repositioning, bleeding and all that. We want to get that pressure taken off of there so that it becomes a neutral light issue. So then we install our locks. This is number 4 in the procedure. We install the locks. Once again, goes on. In the newer systems of today, the tag is actually a part of the lock itself. So that helps to help us to identify it. But we attach the tag to the lock saying who locked it out, why, and what's going on to it. And once again, one lock, one tag per person. So if I got multiple people, we're going to have multiple locks. And then try it. Make sure that if we've locked it out, that we have stopped the energy source, attempt to restart the process and verify that it's locked out. That's in industry, that needs to be watched very carefully. Once we've proceeded with our lockout tagout, we know that everything's stable and secure, then we can begin our maintenance work. We go on about what we need to do. We go in, we make the repairs, we make the adjustments, whatever. We come back out and we account for everybody and all of our tools and everything. Everything is in place. So then the equipment is back intact, and then we can start the restart procedures. So once again, we notified everybody when the equipment and all that was going to be shut down, when it was going to be inoperable. Now that we've applied everything or done everything, we could then go back and start re-energizing and bringing everything back up online. So it's really a procedure. Once again, we notify, we do the work, and now we're notifying everybody that we're coming back up. Okay, and then we also ensure that everybody is in a safe position so that they don't get surprised by the startup. Everybody needs to know. We take off our locks, and that once again starts the equipment and verify that everything's working properly. The other thing too that's very critical here is lockout tagout devices are specific for lockout tagout. We don't use padlocks and all that from lockout tagout to go secure our lockers or anything like that personally. These are in place for a reason so that they are used specific to this. They are provided by the employers. They are standardized in their colors and shapes. They're very durable. So that, you know, there is indoor and outdoor situations where this is done. So we want to very much understand that they're tough, but most of all, that they are specific to one job only. Here we can see some different types of lockout devices. We got the padlock and key. We've got a hasp. This would be used if I've got multiple people in the process that are entering the space. I've got a breaker, a pole breaker that would go on there. In the upper right corner here, we've got a circuit breaker lock. We have blanking systems and all that down here. If I've got valves in air lines, water lines, anything like that, where we can blank those off. And then we have a cable and locks that if I have like an OS&Y valve here or something that has a handle to screw it open, we can lock that so that it can't be moved. We have a cord block that goes on the end of an extension cord. And last but not least, even a switch that can go on a wall switch in a room. Because I mean, how common could it be that I'm working in the bathroom or something and I'm updating a light fixture or something and somebody walks in just out of habit and flips the switch walking in. So it can happen. So we want to make sure we've taken care of that so that it can't be accidentally turned on. These are lockout tagout devices for vehicles. Okay, we've got an example here of where a vehicle's been disabled, a forklift or whatever. So the steering wheel's locked out. Different devices here that lock between the pedals. You can see all this, there are barriers that say this vehicle is out of service, and it's very obvious. So lockout and tagout devices are very durable. They are standardized, the print and format, so that it's all the same. So every time we see it, we recognize and understand that that's exactly what it is. They take a pretty fair amount of force if somebody tried to tear it off or anything. Some of them are not reusable, and they're self-locking. Okay, the unlock strength is 50 pounds on that. So anyway, but the point is if it's there for a reason. Don't mess with it. And the person who's got it there, that would be the person to talk to. So once again, our control program, lockout, tagout procedures. We want to train our employees that everybody's up to speed. We do periodic inspections, enforcement, written, and full employee protection. That's our bottom line, is we're here protecting our people because they are our biggest asset and our resource. Okay. So lockout or tryout. Once again, energy control, scope and purpose, steps to control energy, lockout devices. Here's once again our 8 steps to prepare for the shutdown. Once again, it's saying in the North Electrical Shed, this is just examples of an example of a lockout, tagout, what they're going to be doing, where and when and how. Okay, reiterating here once again, all workers need to be trained on this, so everybody's on the same page, whether it's a 20-year employee or the new kid on the block. It all plays that way. Authorized people, affected employees, this all plays into it. Whoever works with it needs to know how the systems work, however they are specific for you, your operation, your business, whatever. Okay, procedures, we're just reiterating here once again. Once again, we train our personnel. We train them on the areas where they're working. Understand, this is how you would lock your part out here. Okay, recognize the hazard, the energy sources, the types of magnitudes, how to isolate, and what method or what means am I going to use to do the lockout, tagout? Do I use a padlock? Do I use a blank? Do I use cables? What different things do I need to be able to do this? Okay. We also want to retrain, say somebody's in a job position or takes a different position, they're now moving into a different part of the facility or whatever, we would then want to train them on what lockout, tagout things they need to do specific to where they're working now. So it's retraining anytime a job would change. Periodic inspections, once again, we're inspecting our properties and all that. So we may have to do lockout, tagout when we're inspecting part of our equipment and things like that. So all these play right down here, identify and correct all those procedures. So why lockout, tagout on the family farm? Once again, a lot of farm injuries happen out there. We have, once again, a father and son discussed the need to check a cross auger on a bin. Nobody thought about lockout, tagout. So the dad went to check the auger and didn't like what he heard. So he got on top of the bin and stuck his arm in the auger. The son decided to check the auger and the father lost his forearm. So once again, bad communication, no lockout, tagout. Once again, a simple padlock would have saved this man's arm. It's just that simple. Okay. So lockout, tagout's a small change, but it has a big impact. It doesn't take much to do it. It's not expensive, but everybody goes home, and that's our bottom line. Okay. That's what we're after. I want to thank you for your time, and we're going to move now to the hands-on proportion. So we're going to be moving here for a second. So Barb.
All right. Well, thank you, Dave. That was really amazing. So while Dave is moving to the demonstration area, we're going to put up a quick poll. Please take a few seconds to take this poll. The poll serves to see what you've learned and to test your knowledge in the next presentation. Be sure to keep dropping those questions in the chat box. Everybody's got some good communication going on. Dave will answer a few questions after his demonstration, and there'll be opportunities to ask more at the end. Oh. All right, Dave is there. So we are going to move on to the demonstration portion. Everybody keep finishing up their polls.
Okay.
And here we go,
What we're
Dave.
demonstrating here is this is a device in a machine operation. We got a dump pit auger and the grain leg. So we're going to start them up, and we notice that we've got power. So we shut it down, we stop it, we come over here to motor disconnect. And pull this down. I install my lock through the part where the arm can't move. And once again, that was a bad procedure. I should have been facing away. That's my call. So once again, I go here and I locked out, tag out. Now I try it out. Nope, I didn't get everything. So now what I got to do is I got to go to my second point of entry. All right. I go in here and I shut off this one. I think it is. My lock device goes on the breaker. You can see here, it goes on. Snugly like so. This comes over. My padlock goes through here. Notice the padlock has a tag. It says locked out. So we now have everything taken care of, our energy sources. So we now have everything locked out, and now procedures can go on from there. So this pretty much concludes lockout, tagout. Once again, I want to reiterate everyone that it's easy. It can be this simple. This is what saves lives. This is also inexpensive, and keep everybody on the same page, because the bottom line is everybody goes home. So thank you for your time.
All right, Dave, I've got a few questions out here for
Can't hear anything.
questions and some comments. So thank you, everybody. Keep them coming. There was a general comment on one of the pictures. Whoop, I think Dave's moving back to the other area. There, yep. Stay there, Dave.
Okay.
So there's just a general comment on one of the pictures about the person should be standing to the right, not the left of a particular breaker, just in case the door blows off, his arm would get.
Sorry about that. Be something like this. My
Okay,
mistake. That was my mistake in the presentation. Sorry about that. Good catch.
nope, that's okay, everyone. And you know what? That's why we're all here together today. Let's see. Somebody was asking, does anybody else, do people have a hard time getting employees to use a lockout tagout system? They said their crews and small groups usually have to go through it 2 to 3, 4 times or asked to convince them to do it. And somebody brought up discipline. What are your thoughts on that, Dave?
If they ever lose a coworker, or if I was the son and my dad lost his arm, lockout tagout would be pretty good, would be very, very, very important to me. So, it may seem like you're just preaching to the choir, but keep preaching, because you're going to take your safety of your employees is critical, and you need to make it as stringent as you need to. But above all, we just got to get them to buy in, because it's their lives and their safety. And it's just that critical.
Right. I mean, what do you think about the discipline part?
I would leave that up to the companies themselves. If I've got a person that just doesn't buy into it, I think I'm going to train them till they get sick of it, till they do it. So, I'm not going to go, discipline's up to them, but I'm going to train them to where they understand my expectation is you are going to do this.
Yes. Yep. So a question on going back to, again, one of your slides. It says OSHA does not recognize a light switch as an energy isolating device, is they have a high failure rate, but also isn't turning off a light switch part of lockout tagout anyway. Where instead of just a switch, would you go another step?
Yes, I would go ahead. The switch is just part of it. I've identified that, but I would also go back to the source, the breaker or whatever, and secure it there.
Okay. Yep. Yep. Okay, so if using lockout tagout stations with other devices, it says make sure the locks and devices are available in convenient locations. So just another little extra help there. But should a placard be placed next to the equipment requiring lockout tagout?
Yeah, I don't think that you can't, I don't think you can go too far. I think if it's equipment, you're going to understand what the equipment does for you. So yeah, I'm going to placard whatever I need to lock out. If I'm going into work on a certain piece of machinery, this piece is included in what we would lock out and tag out.
Okay, and also, do you need to be competent to apply the lockout tag out?
Well, that's kind of why we did the qualified employees and all that versus the new employees until they're all up to speed on the procedure and the expectation. It's not about competence, about comfort and understanding that this is just how we do it. I emphasize too that, and I don't care if you're the 20-year employee or the brand new employee, we do it right, and we always do it right, no matter who you are.
Right. Yeah. Just a few other comments here. Just, everybody should have standard operating procedures in place near it, and lockout tag should be part of that procedure.
Yeah.
There's what do you think about training employees to put hasps through the energy source?
To put what now?
The hasp. Put a hasp.
Anytime, if it's any more than one employee going into the area to do the work, then you use the hasp because two people. If you just put it with your lock that you use, that's okay, even if it's a single, because something happens where if I have to go get an employee to help me, it's already locked out that he can just add his lock. So it's not right or wrong to use the hasp, but it is if you have more than one person.
Okay. I think we're gonna stop with the Q&A here for now, and people can ask more questions at the end. We're gonna have a panel discussion. That way we can get on with the next presentation and demo. Thank you very much, Dave, for answering those questions for us.
Thank you. Appreciate the opportunity.
All right, we're gonna move on to our next presenter then. Our presenter is Paul Ronskowski. Paul recently retired as a professor from the Illinois State University in Occupational Safety and Health program. He taught courses in construction safety and health, agriculture safety and health, OSHA general industry standards, and the NFPA life safety codes. Paul continues to serve as a program's internship coordinator as an adjunct, and additionally, Paul was the faculty advisor for the student section of the American Society of Safety Professionals. This section received an Outstanding Student Section of the Year award in 2017 and 2019 under Paul's leadership. Way to go, Paul, in bringing those young people into the industry and teaching them safety. But one of the only 5 student sections that has won this award twice. In 2019, the student group was recognized for their research on machine guarding for agriculture harvest equipment. And Paul currently owns White Eagle Occupational Safety and Health Services in Cameron, Missouri. So thank you, Paul, and tell us a little bit about yourself.
Well, thanks, Barb. I think you did my intro there was more than adequate, but I do have a passion for safety, been doing it for a long time. And I think, especially in agricultural safety, I grew up on a farm. And so there is a little bit in my heart of keeping our farmers safe. So that's why I enjoy doing this. So today I'm going to talk about bins, ladders and stairs on our around our bins, and work through ladders. We're basically going to talk about ladders and stairways today. But just to make sure you understand, there's other considerations out there when we have falls, and we're looking at falls around the farm for our commercial grain elevators, floor openings, elevated work surfaces, elevated walkways. But like I said, we're just focusing on ladders and stairways out of the general industry standards that you see there. And starting off, you hear a lot from OSHA talks about our fatalities, and we like to look at the number of fatalities that we have within industry or certain tasks and that kind of a thing, because that's maybe a better indicator of how hazardous an industry or a task is. Yeah, we have a lot of injuries, but I wanted to focus on fatalities, and we hear from OSHA, even if you're small family farms and you're not covered by OSHA, it really doesn't matter because we're talking about best practices here. And we hear that about 20% of our falls every year are off of ladders. But I wanted to focus on this slide here a little bit. The Bureau of Labor Statistics, which is part of the Department of Labor, did this study, or a 5-year study, as you see here, from 2011 to 16. And they looked at all falls. So you're talking about roofs and construction and your elevated surfaces, machinery, whatever. But if you notice here, at the different heights of people working off ladders, notice the number of fatalities we have working off of ladders. And this to me is what I hope maybe gets some attention here, or at least you think about it. Understanding that we usually think of, hey, if I'm working up at a very high height, that's when I got to start worrying about falling. No, look at this. 22% of our falls from ladders occur at less than 6 feet. In this study, that was about almost 90 people died working off of ladders less than 6 feet. 6 to 10 feet. That was about 174, 75 people died working off those heights. And you see the number of fatalities decrease as we get up in those higher heights. That part of that is because of the limitations that we have with our ladders, which you're going to see on one of my slides here. So keep this in mind. We can fall, hurt ourselves, or be killed from pretty much any height on a ladder. When we look at the types of ladders, we start to look at choosing the correct ladder. You'll notice on the bottom here, we've got the ANSI standards for the different types of ladders that we have. And when we look at farming, commercial grain elevators, we want to focus on that type 1, type 1A, type 1AA type of ladder. A lot of people, unfortunately, we see using those type 3 light duty aluminum ladders. The reason? They're light, they're easy to move around. And the fiberglass ladder is a little more heavier, but the aluminum ones are conductive, the side rails are conductive, whereas your fiberglass are not. And when we look at the load limit, we see that we have to consider not only the user's weight, but personal protective equipment that they have, tools on their tool belt, these kinds of things. And we have to consider that in these weights that we are using here. This link here, I've got it from Warner Ladder, but any ladder company that, wherever you get your ladders, they got a website, a beautiful website. They all have information that is very valuable to you on choosing the right ladder. And here is the limitations that we see with our extension ladders, where the longest one we can get is 40 feet. And you can see that where that gets you on your height of work. That's quite a ways up there. Our step ladders, 16 feet is the maximum height that we're gonna have with a step ladder, which gets you to around 20 feet. So that's getting up there quite a bit. In choosing the ladder, and some of the pictures I have coming up here, choosing the right ladder is important. Do I use an extension ladder for this particular job? Do I use a step ladder? Because picking the wrong one can cause you to actually make things more unsafe for you, because you have to use the ladder incorrectly. And then ladders are designed for a certain purpose. Our ladders are designed to take vertical loads, as you see on this little slide here. They are not designed to take horizontal loads. So we don't want to see a ladder used horizontally as a scaffold or a pickboard, something of that nature. We also will look at step ladders. We're going to see where people like to use step ladders incorrectly. They try to use them as an extension ladder. The step ladder is not designed to be used as an extension ladder. It's designed to have the spreader bars locked out and used as a step ladder. So we looked at that chart that shows us what's the right height to use on our extension ladder so that we consider the maximum working height that we are having. We also have to consider where we're using this ladder. If we're inside of a building, are the ceiling heights going to restrict what we can use? We also have to consider, for example, when we use an extension ladder, the gap that's created between the wall here and the ladder, if we are using the extension ladder to do work along that sidewall. So if we have too long of a ladder, our gap is going to be wider, and then we can't reach our work area. So we have to consider that as well. When we use our ladders, it doesn't matter if we're using fixed ladders, talk a little bit about that. If we're using step ladders or extension ladders, we want to face the ladder. We never use them as a stair, for example. We're always facing the ladder. As we see in the left slide here, OSHA talks about in their standards 3 points of contact. They also talk about, though, grasp, at least grasping with one hand, so that you have I like to use the term control, that you have better control, because I have had people come up to me and say, hey, if I'm leaning against the ladder and I got my belt buckles on the ladder, is that a point of contact? Well, you're not really grasping anything then. So we want to talk about, as we're ascending and descending, that we have 3 points of contact, but we have grasp on a rung at least with one hand, as the other one is going up to the next rung. Good rule of thumb is keep that belt buckle in the center of the rails at all times, and you're in good shape. Too many times we see people they don't want to move the extension ladder, or they don't want to move the step ladder. We got to get over here a little bit, so we're going to reach out a little. Now we have a stability issue with the ladder. Carrying tools. We now lose, if we're grabbing a bunch of tools or several tools in our hand, now we lose that 3 point contact, that grasping control, because now we only have one hand that can be used. So let's consider a 5-gallon bucket, put your tools in there. You've got, once you get up there, you haul it up. This is a great picture because you're behind a guardrail, so you're protected from your fall. But tool belts, the use of tool belts as well. Here's a good example on working on a grain bin where we've got a step ladder, and probably not the right ladder to use for this situation. The reason is he can't do his work properly to face that using the step ladder. So now he's using the step ladder incorrectly, depending on the type of step ladder. Some step ladders you're allowed to access both sides, but that's determined by the manufacturer of the ladder. So looking at, do we use an extension ladder? The other part here too is we don't ever want to straddle a step ladder when we're using it. Again, we lose stability when we're using that ladder in this manner. Defective ladders. We want to make sure that the ladder is, as you see here, we've got splits that are going to affect the integrity. We've got some smashed support pieces on the back side of this ladder. We might have rivets that are knocked out of it. Other pieces that are broken. The feet we'll show you in our demonstration. Here you see one of the rubber feet is missing on this one. This one's pretty worn out here. And that now affects the integrity of that ladder and its ability to do what it was designed to do. The use of an extension ladder, an important thing, and some of you may have heard this before, but we always want to achieve a 4-to-1 ratio of our step ladder, whether we are using our extension ladder, whether we're using our extension ladder to do work, or as this little diagram is showing here, he's going to use this ladder to access another level. So our side rails are always going to, both side rails are going to be on that level where we're accessing, or at the side of the wall where we're going to be doing some work. We then consider the vertical height. In this case, it's 8 feet. So our feet of the ladder are going to be set up 2 feet from the wall to get us this 4-to-1 ratio, which creates approximately a 75-degree angle. Now, we can eyeball a little bit, which isn't, well, we're going to show you a slide here. You can kind of do it. If you know what the heights are, that's the best way. But we'll show you some things when we get to the next slide. So as I've got here, we're going to use that extension ladder to either access or to do work. And when we do, we're going to secure the top, the bottom, or both, depending on our situation. But at least one of these, as we see in the bottom here, we've got the feet secured at the bottom so that that ladder doesn't kick out when we're using it. If we are using an extension, we want to make sure that those rungs, the rung locks that we find on them, are locked in place, both of them. And if we are using the extension to access, two things: we're going to have a 3-foot extension here, but also if we're using our extension, is the two pieces should overlap at least 3 feet so that we have good support. And usually your ladder labels will tell you where to go on that overlap of your two sections of your extension ladder. So here's a 3-foot extension I was talking about here when I'm using the ladder to access. I've got something to grab onto. Another thing we want to make sure of is once we get up on this roof here, we've got fall protection for that worker once they're up there. They make many nice types of devices where you can walk through your extension ladder with a locking gate that automatically closes behind you and gives you fall protection. You got guardrails on the side, that kind of a thing. So making sure that we have fall protection if we're using that using that for access. Now here on this bin, if we look at this ladder, if I'm doing work off this ladder, I'm in pretty good shape. We'll take a look. We got some schematics coming up here, but if I were to try to access the roof hatch here, well, this is not a good way to set this ladder up. Now I want that, make sure I've got a long enough ladder, and I would here, that extends 3 feet above where that roof hatch is going to be. In this case, since I don't have any other kinds of fall protection up there, my only job is I can probably open up the bin, the hatch, look inside and take a look at something. But now if we're trying to determine, do I have this at the 4-to-1 angle? Well, if I know what the heights are here, I can maybe walk them off a little bit. So that 4-to-1 ratio, as we've got here, we take a look at that. We've got a 90-degree angle that's created in the red lines. Half of that is a 45-degree angle. And then if we take this half between the blue and the red, half of that 45 is 22.5 feet. Add that to 45. I'm roughly, if I'm halfway between those two, I'm going to be at 60. I can't do math in my head, but a little over 67 feet, something like that. And so now I'm a little bit more than that halfway point. And I look like I'm in pretty good shape of meeting that approximately 75-degree angle with that ladder. Okay, our step ladders. We want to make sure we fully extend the spreaders. We never want to step beyond the top step of the ladder. We'll show you what we're talking about when we look at our demonstrations there. Showing you some incorrect use of a step ladder here is we've got it as kind of an extension ladder. So the spreaders obviously are not in place. It doesn't have a good stability. It's not designed to be used this way. Going to use an extension ladder. My question would be, with this grain bin, why didn't they have maybe a stair system, small stair system going up with this one here? Now, I show you this one because there are special purpose or specialty ladders that are out there. This is a type of step ladder that this cross step can be used as an extension ladder, as you see here. It's designed to fit on a corner, as you see in this picture here, or it can be laid up against the side of a wall to be used. But that's a specialty ladder that is designed and approved by ANSI to be used for that. Single rail ladders are prohibited. As you see here, this wood ladder, these are prohibited. They are dangerous. Our feet can slide off the sides here as we go up and down these things. And this is taken from a grain elevator. Ladder storage, very important. We want to keep our ladders away from heat, sunlight, moisture. It can affect the integrity of the fiberglass as it's exposed to the weather. Having brackets to prevent any kind of sag and having them stored vertically and secured is a proper way to store our ladders. Here's an example of why we want to store our ladders in a good manner, in a good area. This was from Washington OSHA, investigated a fatality where this fiberglass ladder had been stored outside for many, many years. It affected the integrity of the fiberglass when the worker went to use it. As you can see here, both side rails shattered, collapsed, he fell to his death. The final thing now is I wanted to mention a little bit about fixed ladders because I've run across farmers who are wondering, like, you know, we're building some new grain bins and we don't see these fixed ladders on them anywhere. We're seeing stairs or stair towers. And that's because we are phasing out the use of fixed ladders as we currently understand them. As you see here, if the fixed ladder was installed before 2018, you can still use it up until 2036. At that point in time, you have to have a ladder safety system or a personal fall arrest system on that fixed ladder. But many manufacturers are already anticipating that and not even using the fixed ladders. They are going straight to the stair systems. But if you have that system installed before 2018, you can have ladder cages around them, but the ladder cages, as we see here, they don't consider them fall protection, but I always wondered, like, is it really fall protection? Because the purpose or the theory is that if I fell off this ladder, that my arms get hooked into, or I grab that cage, prevent myself from falling. And just think about that for a second as you try to use it. Guys would also use them in a manner which they're not designed for, is to lean against them to rest. And there have been fatalities because a guy gets down at the end of the cage. The cage is going to be about 7 or 8 feet from the ground. He's down there at about 6 feet. He's going to take a rest or whatever, forgets there's no cage there and falls just 6 feet to his death. So as you have these older fixed ladders, start thinking about a replacement schedule for the ladder safety device, or go to stair towers when we have that. So the way it's going to look, and here is an existing caged fixed ladder system. So if your fixed ladder is 24 feet above a lower level, it's going to require the cage right now for the older systems, but will require then the ladder safety system you see here. I do mention that an option is a personal fall arrest system. Personally, I don't think you're going to see that much in the grain industry, because you need, for a personal fall arrest system on your ladders, you need an anchor point above you, and you need a self-retracting lanyard in order for that to work right. What you're going to see a lot of are these ladder safety devices, ladder safety systems, which we're going to talk about. So here's what we see most of is and as our new bins are going up, is stair towers or stair systems to access them. Final couple of slides here, just to make sure, even though we have stair systems, which are good, much better than having to use a ladder, we got to be aware of, we don't want to be using them when we have some ice. We want to make sure we've got some good graded type of treads on there so that water drains off them, things of that nature. Always use our handrails on our stairs. Don't be skipping steps, and making sure we take our time going up and down, and we'll be in good shape. Okay, so we're going to move over, take a look at a couple of things in the other room here, and we'll see you in a couple of minutes.
All right, thanks, Paul. While Paul is moving to the demonstration area, we're going to put up a quick poll. So take a few seconds to show us what you learned from Paul. And then we're going to, and be sure to drop a few questions in the chat box that Paul can answer, a few right after his demonstration, and then there'll be an opportunity for more questions later. Hey, don't forget to register for Friday's session on emergency action plans. And we've got a special guest, and that's Brian Bothist from Region 5 OSHA, to give us some updates on OSHA's new COVID guidelines and the National Emphasis Program. So go to standupforgrainsafety.org to register and to find other resources for other topics. Oh, looks like we're getting some great answers in there in our poll. So keep dropping your questions in the chat box. And our trainers will be available at the end of the session for questions. And don't forget to check those out. So it looks like Paul is ready there for our demo. So we're going to shoot into the demo center. Thank you.
Okay, all right. So we're taking a look at a good step ladder here, brand new one. Here is what we call the cap. And as you'll see, there's a label here. You won't be able to see it here, but it says, do not stand at or above this level. This is the top step of the ladder. Many people think this is, and they say, okay, I can step up here. Wrong, okay? We need a different size ladder if we need to step up here to reach something, okay? So this is the top step. Here is as high as we ever go with this type of step ladder. The other thing is, you'll notice we have various labels on our ladders, okay? We want to make sure that those labels are on there. They've got some important information on the safety and use of this ladder. And here's the beauty of it. If the labels come off, and I've seen them, it's just aging a little bit, call up, this is a Werner ladder. If it's Keller, whatever your ladder company is, call them up. They'll send you new ones, okay? And then you know the type of ladder you've got. We've got a type 2 here, which is 225 pounds. So, or yeah, something right there. So make sure all those things are in place. We've got a nice damaged ladder here. Here I can tell, here's the old, you don't see the aluminum caps too much anymore. Most of them are that plastic cap, but someone was standing on here. Obviously, when I see that, the label there was a label here, but it's all torn up, covered with paint, missing. But this person or people use that top here. The other thing is you can kind of see it's not stable. Okay, we have some problems with the feet on the bottom. One of them is really worn out for whatever reason. And so we have different heights on our feet. We have spray paint all over this, which can affect the integrity of that fiberglass. So we do tag it out, as we saw, that says danger, take it out of service, and we don't use it. Okay, so that'll be part of our inspections. Over here, we're going to do our little demonstration. Here is a ladder safety system. And the system, as you see here, we've got our cage on this fixed ladder here. The system allows you, when we hook John up to this thing, to move up the ladder. But if he were to fall or slip, it's going to catch him. It's got a two-step locking mechanism carabiner on it so that it doesn't pop out while it's attached to him. And the other thing we'll point out is that when you install your ladder safety system, you can keep your cage up here. You don't have to have a cage once you have this system in here, but you can keep it on, so you don't have to take it down. So we're going to get John on this now, and we're going to attach him to it. As John's attaching this, you're going to see he's got a proper harness. We've got our other safety equipment on as needed, gloves for good grasp, okay? And the other thing is, notice that we got some work to do. We have the ladder safety system in place. We got to make sure this is in place, everything's in place. We got to make sure we got our body harness on. We got to make sure the worker knows how to use it. So if we don't have to use this system, in other words, using stairs, boy, that's just a bunch of stuff we take out of the equation. So if we can have stairs, a much better system. All right, John's going to go up and show you how this works. So he slips. He slips off it, and you can see he's hanging there. Okay. Okay. So anything else you want to add to that?
Cable tension.
Oh,
Make sure the cable's in there. Right.
yeah. Make sure the cable is in proper tension. When they install this, you're not going to be installing these on your own. You're going to have a company in here, because yeah, if you have too much, if it's not tensioned properly, and you have too much slack, it's not going to work properly. Okay. All right. That's it.
All right, thank you. We've got a few questions out there for you, Paul.
Okay.
First, is there a height requirement for pass-through fixed ladders? For instance, does a 4 or 5 ladder need to have an extended beam for a pass-through?
Hit the top and you come through.
Oh, okay. When you get to the
Get to the very top.
get to the very top, forget there's
I
a,
believe it's 42 inches. Right?
yeah, you're talking about if they're talking about the platform is
The ladder's fixed in 42 inches above the platform.
oh, okay, now I've got it. Yeah, 42 inches above the platform, correct, is the ladder goes past, so that you've got something to grab onto and then step onto the platform. Okay, I wasn't understanding it. Okay.
Well, and I may not have read it very well for you, but thank you guys for working that out for us. And just there's been numerous comments in there, not necessarily questions, but just want to remind everybody that different states do have different regulations, kind of as noted by CJ in the chat. He was talking about California OSHA is required on top of an extension ladder to descend over, not from the side of the ladder, again, due to stability. So just again, a reminder to make sure everyone knows what the regs are in their state. Hey, since you have that system on, somebody asked, what is the personal weight limit for a ladder safety system?
That is, well, they tested, the system's tested, first of all, the distance between his connection and the carabiner here is 9 inches. And then it's tested by an 18-inch drop with a 500-pound weight on. But you do have to, as far as your body harnesses are, there are different body harness. There's different types of body harness based on an employee's weight. So you do have to have the right
I
body.
believe it's 500 pounds, but I have to look it up.
Yeah, 500 pounds on that test weight,
Yeah.
but the body harnesses.
Flying horse is like 410.
Yeah, and then you get one that's for smaller. If you're really small, there's no body harness that really works well. So.
And then everywhere they connect this, the U-bolts, they put a steel rod through it to beef it up. Because this is just rolled galvanized, it's not very strong. So everywhere it's connected, you have to beef that up, just rung up.
Okay, and I guess they were also asking about, is there a weight limit for the height of the ladder? Asking about the requirement of the height of the ladder. And again, if this is something you can't spot,
No.
we can come back to it. Let's see. Is anyone aware of any hard numbers, like in years, for replacing a fiberglass ladder?
Yeah. One of the things is to look at your manufacturer. Actually, John and I were just talking about some companies that have their portable ladders stored on their trucks. And even though they have boom trucks and they're using those a lot, and they don't use the ladders, they are recycling them out every 4 or 5 years or something like that. So I would look at your manufacturer of the ladders on those kinds of things. Your storage is going to have a big impact on how long your ladder's kept.
Correct. And you did talk to us about that in your presentation, proper storage of ladders. So thank you for that. Again, there were numerous questions from people, again, talking about different states. One of the questions, and I won't expect you to answer it, but does anyone know if OSHA has given an interpretation regarding whether or not platforms are considered a lower level?
You faded out on the what or what?
Does anyone know if OSHA has given an interpretation regarding whether or not platforms are considered a lower level? They understood bin manufacturers believe this to be the case. But again, if it's not something you can answer right now, this is something we can always get back to people
My
on.
knowledge, no. I think I know what they're getting at there. It's for the offsets, like the 30-foot offsets.
Yeah.
Can you bring that down to 20 feet and then put a cage on there and not have a cable on it? And so you're below the 24-foot rule where I think, Larry, you have to have a cable on there when you get to 24 feet or more. And then if you bring the platform down to 20 feet, can you guard guard the cage, guard the handrail, put a swing gate on it? To my knowledge, no, that has not been answered. And I watched that pretty closely.
Yeah.
Okay.
And I don't think it ever will be. But that's my gut feeling on that one.
I think we're going to go ahead and stop the Q&A right here, and we can take more questions certainly at the end with panel discussion. Thank you so much, Paul and John Lee. And we are going to move on to Butch. Butch is next up, talking about safety in and around bins. Butch Hendrix is the safety director for Kokomo Grain, and he also has over 30 years experience in management and safety in the commercial grain industry, in addition to serving for over 30 years in fire and rescue services and as a police chief in a small Illinois town. Butch has 3 grown children, 5 grandkids, and some very spoiled dogs. And so he's given us some good time here today. When Butch isn't busy serving his community, he likes to run, bike, camp with his family. And I tell you what, I've seen on his Facebook page some great woodworking projects. So, hey, Butch, take it away.
All right. Well, thank you very much, Barb. You're right. I do get a little busy from time to time, but we're going to talk today a little bit about grain bin safety and some safety around the grain bins. And basically, this is my contact information for anybody who is interested. And so when we talk about grain bins, there's a number of different standards. Now, standards versus best practices, when we start looking at these, 272 is the grain handling standard for OSHA. And based on that, the other standards that would comply with that would be like ANSI, or you got grain bin standards from manufacturers, and there's a garden variety of other ones that could be referenced by OSHA. And then also keep in mind your state plans there again are pretty much the ability to be a little more strict than what federal OSHA is. Now, when we come to the actual family farms, most generally the family farms they're not that they're exempt, that they are not covered by federal OSHA, and therefore these would be under best practices. We use those best practices at those locations because they do work. That's why we recommend them. And just going back on the last presentation with Paul, I was talking about some stairways and some ladders, platforms, and when you look at the legs, you got ladders and platforms and everything you have also. So not to spend a lot of time on that. So out in the demo area, we have a sweep auger out there, and they're going to show it on a camera for us. And basically what we're looking at here, some of the things to be concerned with sweep augers are unguarded. And also the small ones with the wheels on the ends of them, you got to watch for them. So once they start wearing down, it kind of gets to the point where they won't pull themselves. That's where people start kicking them. And when people start kicking them, that's when their pant legs get caught and we start seeing fatalities and or possibility of amputations and everything. Flighting on these, especially after they've been used for a little while, they get very extremely sharp. And the equipment guarding is based on the picture you see, the video. You'll see the handrail in place, and you also have to have that snow fence or something of that nature. And what that does, that's going to keep a person's arm from going through and getting into the sweep auger itself. Down on the end of that, you'll see a area where it's covered and also has a handrail around it and the netting on it as well. And that's your sump guard. So your center sump's going to be covered in that. So anytime you're working on these things and going into these bins, you want to lock those out. And of course, that's going to be a common theme you hear throughout all these different items when we start talking about equipment, is locking out. So when we talk about sump guards, we also have what we call floor sumps. And those floor sumps you see on the picture in the upper left-hand corner, some of those augers are pretty darn close. And if you don't keep those covered up and you happen to step in one of those, like I said, those things are very sharp. This is where people get injured and are killed, because the fact that that auger is going to run, it's going to move whatever it moves, whether it's a kernel or corner or whether it's your foot. So you want to make sure that you keep your guards in place for those. So left side, those are no-goes. The right side, if you look on the upper right-hand corner, we have a sump cover there. This is for probably maybe a 12 by 12 or something of that nature in the bottom of a bin. And you got to have the jam nuts right here on the corner. If you look at those right there, and what that does is that is where it secures that. So it has to be secured to the point where you can't just accidentally knock it out. All right, so if you look down here on the bottom right, there's sump guards on there as well. Okay, so when we look at augers, one of the other ways to do it, we have augers that load from the outside. We have augers that load the trucks from the bins. And a lot of these for Monday, I think Aaron Yoder was talking about different augers, and one of them was electric, and then we have some that are PTO driven. A few other items is PTO driven. You may see something from a post hole digger. You have your mowers. There's a garden variety of different things that run from a PTO shaft. PTO shafts are very, very dangerous when it comes to it, because they're really out in the open. And if you don't have the guards in place, they can actually cause a lot of damage, because they will wrap you up in a hurry. And we'll hit on that just a little bit more on down the line here a bit. So the drive line securely locked onto the tractor PTO stub shaft. You got to make sure that those things are fully locked in place, because if they fall off, then you start having other issues, and then your exposure goes up as well. So any machine part that rotates, as in shafts, rods, etc., they'll wrap your clothes up in the direction that it's turning. Now, the more you have damage on the shaft, you get nicks and cuts in it, and you'll start getting like little tags that'll grab your clothes. The end result is, if it grabs your clothes, you're not going to have time to react. So PTOs are the most common machinery hazard that we see on the farms. And so that it's something that we want to make sure that we take care of. Now, when we talk about the PTO stub, this is actually going to be this area right here, if you can see the pointer there. And that transmits the power from the tractor to our equipment. And at 540 RPMs, that thing's rotating 9 times per second. And at 1000 RPMs, it's rotating 16.6 times per second. So you want to make sure you have that general guard over the top of that, as long as the guard on the shaft itself, and that's going to be considered your master shield. And basically what that's going to do, you don't want to step on that, because it's, it's the same thing with a guard on an auger. You don't want to step on one of the top covers from an auger, because of the fact that it could fall through, or you could have another situation. Then you're exposed to the rotating shaft. All right, so where we talk about machine hazards and where they occur at, if it moves, basically it can cause an injury, and it's got to be guarded. So you got point of operations, power transmission apparatus, and a few moving parts. Point of operation, this is actually where the actual work is performed. You think about like power presses and that kind of stuff. You have like a die or something of that nature. That's where your actual work is taken care of. And it's also a pinch point. Your point of operation on your grinders up here, you'll have guards on the end of those, and all the platforms and the tongue guards and all that stuff. There's a reason why those things are supposed to be smaller openings, and that's if your wheel blows up and it contains it within that guard. Sweep augers, again, we see those augers with the guard across the back. It's basically a cover. Add the handrails and the fencing, and that'll keep anybody from getting their hands in it. And preferably with a 7-foot long dead man switch, you can actually turn it on and off with that. Excuse me. And that also helps for keeping you away from that piece of equipment. So when we look at machine hazards, pinch points, wrap points, pull-in points, shear points, crush points, there's a garden variety of them. I mean, we just have, if it's a piece of equipment that moves, you can see a problem with it, right? So the one that you see in the picture right there, I go by grain bins all the time out in the country. And if somebody has to change a belt on that thing, what they do is they take that guard off, and then instead of trying to put the 4 or 5 bolts back in it to secure it, they just leave it off. And if you walk by that too close and while it's running, your pant leg can get wrapped up in that just as well as it does with like a PTO shaft. It's pretty much the same type of mechanism of injury. All right, so mechanics or mechanisms that take crops in or material for processing would be conveyors, feed rollers, feed chambers, grinders, harvest equipment. These are all places that pulls in. A corn head would be a good example, a bean head, that type of stuff. So it's not only just going to be your in-plant stuff. You know, we hear, seems like once or twice a year during harvest, we hear about people getting injured or killed when they're using bean or corn heads on their combines. Shear points. These are something that, you know, it cuts, it moves fast. You don't really have an opportunity to get in there to do anything. And then some of those are very difficult to work with and guard them because it's kind of in that point of operation type of thing. It has to be open so it'll work. So you have to guard it in other fashions. And the high speed movement, like in the example of a hedge trimmer, or, you know, the old sickle mowers like we used to see, those, they actually are moving fast enough. It's hard to really see where those blades are at. So it may look like there's not much there and it's actually moving pretty rapidly. All right, so when we start looking at crush points come in a variety of issues, like in the dump beds of a truck. I go back to the combines where we have the corn heads and the bean heads. Something happens, there's a jam in it, somebody gets under the corn head and somehow it gets released and it drops down. And I believe there was one of those not too long ago. And so these are always things that we got to do to block them. Okay, so some tractors come now with the buckets. Whenever you look at the buckets, they have a block on them or a lever you can flip over that'll keep them from coming down. They're a little better than they were in the older days. The older days, if your hydraulics were elevated, you walk by and you touch the lever, it would drop all the way to the ground and nothing flat. Nowadays, it's a little bit slower, but you still have the same issue. All right, so freewheeling parts. When we start looking at these, if the machine's turned off and it continues to rotate, it continues to move, or whatever the case is, perfect example, this would be a fan of some sorts. When you shut that power off, it's going to continue to move a little ways. So keep that in mind whenever you're moving around and doing stuff. Once you shut it off, it may take a couple minutes for it to shut down and quit moving. And you got to secure it so you don't have another issue. And we revert back again to lockout tagout. All right, so thrown objects. My goodness, there are so many of these that can come out. You got grinders, you got materials that get chopped up. The machine guard operates like in a mower. It's made to cut objects and it will throw it out the side or the back, whatever the case may be. So, you know, definitely want to make sure you're wearing your proper PPE because, again, I know a lot of them have the chains on them, but if you hit a piece of metal, it can very much fly through those drop chains very easily. And again, on the pinch point as well as confined or stored energy, when that energy is raised and that hydraulic is holding that up, like I said, if you hit the old style lever buckets, that thing's going to come all the way to the ground more than likely. It don't always stop. Some of the newer ones are a little bit better than they used to be, but they are still released. So we want to make sure that we take care of those, block them up, whether it's a lever on the machine that helps block it, whether you have to use like wooden blocks to hold them up. Springs are notorious for stored energy. Capacitors, they store some energy once you shut them down. Transformers may also carry some energy after you shut them down. So sometimes you got to ground those out and let them go before you can actually work on them. All right, so guarding, and we'll look at a couple of places out in the demo area again, and we'll see a couple of guards out there. And what these guards have to do is they protect the operator and others from hazards created by normal machine operation. So if it moves and it can pinch, it can pull, it can cut your arms off or whatever the case, it has to be controlled or eliminated. So obviously engineering out that problem is using a guard. So the guard should work is easy access for maintenance, prevent contact. It's got to be secured to the machine, so you can remove it, but you usually have to have a wrench or some form of a tool to make sure it comes off without easily just pulling it and getting it off out of the way. Protect from falling objects, not create new hazards. You don't want to have it interfering with regular job performance. If you can use if you got bearings in behind that guard, you can use like grease zerks on tubes. And now keep in mind, you may have to use 3 pumps of grease versus 2, but there's going to be a situation where you can grease that from the outside. You don't have to take that guard off. And every time that guard don't come off, that's just one less opportunity for it not to get put back in place. And that just kind of falls in with your easy access for maintenance as well. So when we talk about auto protection, guards have a requirement that you cannot get around them, you can't get under them, and you can't get through them, or you can't get over them to get to the working points. Okay, so that pinch point, that belt, the pulleys, whatever the case is, whatever that's guarding, you have to make sure that that guard is to the point to where they can't get under, over, or around it, so you can't access that. And we'll talk a little bit more about the distance as well here in a minute. Some of the guards that we see, fixed guards is probably your most popular, the one that you see the most of. Those are the ones that's bolted to the piece of equipment. 6-sided guards completely encompass like a pulley. You'll have the front, sides, back, and the front and the sides, the back, top and bottom all covered. Interlocks, we use those when you have one piece of equipment you don't want running unless you got that first piece of equipment running, so they all interlock with each other. Adjusting guards, some of those point of operations, that guard moves with that piece of equipment, so it keeps you out. Another way of adjusting is you got your pullbacks where you push the buttons. You have 2 hands to operate the equipment, and that's going to be more in a metalworking area more so than in a grinding area or a grain area, but those are possible. The self-adjusting are the ones that automatically move with the point of operation. And then guarding devices could be anything. We're seeing more and more of the electronics, like the light curtains, the lasers that actually, if you break that laser beam, it'll shut the equipment down. So a lot of the electronic devices are starting to make a more and more of a prevalent showing out in the world. So, all right. So when we talked about the opening sizes, and that's one of the things we talked about, when you go with the auto, you have limits of how far that hazard is away from that guard. Subpart O in general industry standards talks about this. Now the 1/2 inch to it looks like 1.5 inch opening, you have to be less than 1/4 inch. All right. So if that hazard is 1/2 to 1.5 inches close to that guard, you have to have less than 1/4 inch. Basically, you are not going to be able to get any body parts or tool through that. And then it goes all the way up. And when we talked about the dead man switch, where it moves you 7 feet behind the auger, if you look down at the bottom there, that protective cover is not required because of the fact that you are 7 feet behind. And when you let go of that dead man switch, it actually shuts the equipment down, so it's not going to run while you're up in the front or in that area of the auger itself. All right, so when we start talking about the different hazards, you've heard a lot about the training today, and training recognizing hazards are very, very crucial. Reemphasizing what Dave talked about with the lockout training, that recognizing those hazards, having the standard operating procedures and making those available to your employees, those are all part of your training for your employees on the hazards. You got recognize when they're going to have to be tied off. So if they're going to be over 4 foot high, you got to have some kind of a fall protection. And then also, when do you use an SRL versus a lanyard? So these are all things that we have to work on our employees, and that's all part of the onboarding training and then our annual requirements to make sure everybody's trained properly. So when we talk about learning the methods of machine guarding, we want to make sure that we know which guards need to be in which places. So does it need to be a 6-sided guard? Is it something that's over 7 foot high and the guarding is not as critical as it is whenever it's right down at the ground? What kind of a pinch point? Is it a point of operation? Is it going to be an electronic guard? So what type of guarding goes in what place is very crucial. And a lot of times you don't have to be an engineer to make sure that's going to be done right. So look at it and figure it out. And the regulatory requirements on subpart O is really not that difficult. So they are available online. So you can go to OSHA.gov and get those regulatory requirements anytime you need them. Identify and categorize your mechanical hazards and note where those locations are at, because the fact that down the road, you're going to have to make sure those stay in place. Anytime the work's been done on them, you got to lock it out before you remove that guard. And you got to make sure that that guard's put back in place before it's put back into operation. So it's very important. And the fewer people that are aware of these guards missing or unaware of the hazards that may be available is more opportunity for injury or fatalities. So when we look at the safeguards, we've heard about stairs, we've heard about ladders, we've heard about fall protection systems. These are all areas where we got to make sure that the hazards match, or the safety matches the hazard that's put out there. So whether it's a fall or whether it's an item that could fall from the catwalk onto somebody going under it, or whatever the case is, we want to make sure that we look at these and make sure they're matched up with each other. Machine guards not meeting requirements, we want to make sure that they are done, and then we'll get them all rolling in and get them up to date, and make sure new equipment has the proper guarding on it. Sometimes the new equipment comes in and it's not really up to OSHA standards. Falling objects, we want to make sure that anytime there's objects overhead, you got toe boards on your handrails, put signs up, make sure everybody is warned. And of course, our last protection is the PPE versus the engineering removal. Working under platforms, under scaffolding and everything else, if you're working on them, make sure that the PPE is in place, or you have a net to catch the possibility of objects falling below, or just cover it off and put danger tape up and make sure nobody gets in there. So struck by, workers get hit by things from time to time, flying objects, machinery, vehicles. We want to make sure that we keep people out of the areas of the vehicles, lock out lift controls, block tires, never stand, work, or play under, behind, or raise grain trucks. And then we're also going to talk a little bit about getting run over by vehicles. So In the fall, whenever we're doing harvest, a lot of our elevator people where the hive is, so it's reflective because it gets dark early. We make sure that they're covered. Make sure when you're pushing grain piles or bins or flat buildings, you make sure that you make contact with the operator of the equipment, whether it's a payloader, whether it's a skid steer or whatever the case is. And kind of wrapping up here, we got one that was kind of an unusual and a lot of people don't think about. We have a bin inspection. We require our bins to be inspected. Our insurance company wants us to inspect bins on an annual basis. And part of that reason is because of this situation here. This was actually in southern Indiana. A gentleman was loading a truck and the loadout bin failed. And I'm not sure, ended up being a fatality, but I'm not sure if it was struck by or if it was an engulfment, but he was engulfed with the corn, but I'm not sure what the actual mechanism of injury was. So look at, is that something where the driver needs to be right there underneath that area? Is it, if the operations are there, do they need to have a remote operation device so they don't have to be in that area? So these are all things to kind of look at in those bin inspections and make sure those bins don't let go. Okay, so again, just to reemphasize what Dave said, small changes make big impact, and quite honestly, you're not going to get a whole lot smaller than this lock right here. So it will make a major impact on people's lives. Again, here's my contact information, and we're open for questions.
All right. Hey, thank you, Butch. And we're going to put up another quick poll to answer while we're taking some questions. So don't forget to answer those polls so we can see what you've learned in this session. Butch, is it acceptable for the guard of the shaft to rotate?
I'm sorry, can you repeat the question?
Yeah, is it acceptable for the guard of the shaft to rotate?
Yes.
Okay.
Sometimes like on a PTO shaft, that guard will actually move a little bit, but the bulk majority of the time, the shaft should be inside that guard. And it may rotate a little bit, but it's not going to be enough to wrap up if it's done properly.
Okay. Are guards required on the grinder wire wheels since they are included in the definition of abrasive wheel?
The wire wheel, yes, has to be guarded. And again, your tool platform should be within an 1/8 inch and your tongue guard on the top should be within a 1/4 inch. And on the sides, you want to make sure they're guarded because those little wires do come out, and it's pretty much the same thing with the grinder wheel itself. And then there's also some testing requirements for the grinder wheel to make sure there's no cracks in it.
Great, thank you. I think that was pretty clear on that. And just a few good comments. Richard says, hands-on training in the elevators or mills is a great way to train employees to recognize hazard. And I think that's something we're talking about here throughout this whole week, that hands-on training versus just a piece of paper is very important for everybody's learning process.
Absolutely.
Another comment, altering of equipment from design creates numerous OSHA violations. So we just have to keep that in mind. Thank you, everybody, for answering the polls. If you have any more questions for Butch, go ahead and put them in the chat. We will have a full panel chat at the end. All right, thank you, Butch. And we are going to go ahead and come back to Dave. And Dave is going to present Lifeline for us. All right, here we go. Up again, Dave.
All right, here we go.
And if, Dave, if you could come back on camera.
Technology.
Go.
I think we got it.
Yes.
Okay. So we've talked about lockout, tagout. We've talked about all those protocols. We've talked about ladder safety. We've talked about all the stuff around the bin, all the equipment guarding, all those kinds of things. So one more thing is let's talk about what we got to do if we have to go inside the bin. What that is we use and talk about a lifeline program. And a lifeline system is basically designed. I'm not forwarding. What did I do wrong? Where did I go wrong? All right, I need a little help. Anyway, let's see. Do I stop share, Barb? I don't know. Hey, I'm not forwarding on the PowerPoint. Sorry about that. We got a little technical difficulty here. I went to slideshow and then from beginning.
Thanks, everybody, for your patience.
There we go. All right. Introduction into this lifeline and that you can see here, these were pictures of young men that were involved in an incident in Mount Carroll way back when in 2010. And unfortunately, this is what brought grain bin issues and all that to light on a nationwide exam. Brought it together to the media and everybody's attention nationwide. So this is my contact information. So we're going to talk about it. What we're going to try to cover today is identify the components of the lifeline protection system and how the observer manages it. So this is a two-part deal. Once again, we're trying to break the culture of working around or in bins by yourself. So we'll talk about the observer and then how it protects the internet itself. So why would we want to use a lifeline? Because if we have to go in, we want to be able to be safe. If we've done lockout, tag out, hopefully we've got the grain bin, the grain is stable. And that how it protects us is it won't allow us to go more than waist deep in the grain. We'll talk about how it's set up, protection components, the roles, the observer, and that again, our training here is intended to raise the awareness and the benefits of using a lifeline, the demonstrations and all that. It's not intended to be a how-to training. Okay, this is just so you see how it works and how it helps you. Okay, so use of a lifeline falls under 1910-272 H2I. It is a best practice for farms and farm workers, protects bin entrance from entrapment and engulfment. And once again, that grain in that bin or anywhere else doesn't care if you're the owner, the hired hand, a family member, an employee, whoever. If the grain has the ability to entrap you or engulf you, it will. It does not care who you are. And once again, grain bin entry is the last resort. Okay, let's try to do everything else we have to before we get in the bin. Now, people ask the question, why would you be in the bin to begin with? And I use an old analogy of if I had $1 million in a suitcase, every now and then I'm going to check on it. So yeah, getting in a bin to check the quality of our grain is a part of the process, but there are ways to do it safely. And that's a part of what we're doing today. A lifeline is defined as a component of a fall protection system. Once again, it's one component of a system designed to hang either vertically. Once again, we're working on trying to support you from the top center of the bin. So if something takes you down, it'll hold you up and keep you there. And then once connectors at the center and at the wall. The equipment and procedures, once again, is keep you entrapped, to keep you from becoming entrapped no more than waist deep. Here you can see a slide of all the components and part. Here I am, I've got my harness on. I'm attached to the lifeline. I have a knot passing pulley at the top of the bin near the center. And then I have a wall anchor with a belay device out here at the outside. I am the entrant. They are the observer that's at the door. Once again, now you notice in the picture that at least the observer who is there at the door is at least on a platform. On a bin that didn't have a platform, it would be a very tricky situation to be on the ladder, but you would have to be attached to that ladder in a safe manner so that you can do this work. Once again, we try to always be within line of sight so we can see each other or at least hear each other. When we're working in the bin, we want a maximum of 2 feet of slack in the rope. So that that person, if it's 3 feet from the surface of the grain to your waist, you've got a 1 foot safety cushion. Now in the picture, it shows the lifeline attached to the back of the person. I kind of prefer it to the front in that I can manage it and maintain the slack. It's personal preference how you want to do that. It's protection. It prevents the entry from sinking more than waist deep into the grain. Prevents a fall if a grain surface, say you got on a crust and the crust went out from under you, it would protect you from going down in. Okay. So the lifeline, the components. We have a full body harness. This is a class 3 harness. It goes over the shoulders, around the waist, and around the legs. That's the 3 points. That's the 3-point harness. Okay. We're going to use a knot passing pulley, which is permanently installed in the top of the bin. We're going to use a lifeline rope, a life safety rope. Okay. This is not products that you go to your local farm store and purchase. These are bought from safety equipment people because this is life safety rope. So you want those components, okay? Sidewall anchors are permanently installed. We're gonna have slings, we're gonna have carabiners and belay devices. Once again, here's the class 3 full body harness showing you an example how it distributes the weight. Here's the knot passing pulley. This is attached in the top of the bin at the peak. Allows the ropes and knots and all that to pass through and come back to you where you're working. And this is if something happened, this is what's going to support you from the center of the bin to keep you from going down no more than waist deep. This is a lifeline rope, 7/16, which we considered 1 person, 1/2 inch diameter is considered 2 person. Okay, static kern mantle. This is a rope rescue. This is a rescue quality rope. It does have some stretch to it, which helps you to, it's a little bit of the absorption and shock. Okay, these are examples of sidewall anchors. You can see on the left, that's the anchor attached to the bin, and you can see the belay device there. And then you see on the outside, that's the other side of the anchor where we use a piece of pipe, and this is all engineered, all to be rated to be able to use that. Some slings and sewn loops. These are when we attach components like the belay device and the anchor, we need some kind of a soft link between components. We don't want to go metal to metal. They can be pre-sewn loops, as you can see on the left. Those are manufactured. We also have a loop there made of webbing. And you can also use webbing that's used a water knot. Carabiners, these are an oblong metal ring. These are a connection device, things that you would connect your rope to your harness, things like that. It is an ability to quick connect or disconnect. And then the gate is automatically locking so that once I've clipped in, I let go of it and it stays locked. Things like that. Here's a couple of examples of belay and rope grab devices. These are mechanically oriented. This is what the person at the entrance to the bin would be operating to allow the entrant who's inside using to control the amount of slack they have. It's a constant device. The important thing to understand about this is that if something goes wrong, it's simply hands-free. Let go of it, it locks up and the person does not go down into the grain. It's important to understand that when things go wrong, let go of it. Sometimes that's hard to do, but that's the key point is this: if you go hands-free, it locks up and holds you. Here, once again, we see the setup. The person's inside in their proper harness, got the lifeline and not passing the attendant out here. And you can see another example of the sidewall anchor. Consult the bin manufacturers about your anchoring of the roof and all that for the pulleys. There are design systems out there, but above all, talk to your bin manufacturer to know what your roof and that's rated for so that you can get things set up properly. Okay, so now the entrant and the observer, their roles and responsibilities. Once again, this is a 2-person process. Okay, once again, breaking that culture. We're using the lifeline to prevent an engulfment. We're going to talk to each other as best we can. And the first time, as soon as I get in the bin, this picture is actually me in a 105. I'm going to look at the angle of repose. Is it, if I'm in corn, is it 23 to 25 degrees? Somewhere in that neighborhood, beans can be a little steeper in that. Okay, and then I'm also looking at the grain condition. Do I see anything spoiled? Do I see anything discolored? What about the smell of the grain? Anything going on like that? I'm also going to check my air quality to make sure I've got good quality air to be breathing in there. Okay. The observer, his job, his or her job at the entrance right there is to control the amount of slack that's in the rope. And this can sometimes be a challenge, but we pay it out and take it back and forth, but we're monitoring and trying to keep eye on the person inside at all times and watching what they're doing. Okay. So once again, it's a best practice for all. It's required in commercials. It protects the from being engulfed or entrapped or engulfed. There's 7 basic components to it. We're going to go out here and do a little hands-on real quick, and we'll review them real quick so you can see them. It's anchored at the peak, and that the observer does the slack, and it's not real big in dollars. Okay. So I'm going to now transition over to the training area where we're going to do the hands-on, and I'll be back with you in just a minute.
All right, thanks, Dave. And we are going to transition to our last poll. So if you could please go ahead and answer those questions. And I'd like to take this opportunity to let you know, to give you a disclaimer that this learning session is funded in part under a grant SH 99078 SHO from the Occupational Safety and Health Administration, the U.S. Department of Labor. The materials used were revised under grants SH 26294, 60 F17, SH 22288 SH1, and SH 05033 SH8. Materials do not necessarily reflect the views or policies of the U.S. Department of Labor, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government. And we also want everybody to know about their employee rights. Employees are entitled to a safe and healthy working conditions, fair compensation for all hours worked, and the ability to report unsafe conditions without retaliation. They can call, write, or email the OSHA area office within 30 days to report any employee retaliation. They can go to www.osha.gov and www.whistleblowers.gov.
All right, so we're back here in the training site. Once again, reviewing the components. This is our wall anchor. This is where the clothesline is attached. This is the rope system going up through the knot passing pulley. I have my life safety rope. I have it attached to the lifeline, or to this clothesline, excuse me. So what I'm going to do is I'm going to start passing it, pulling it. So notice how the rope and everything comes through here. Once I get it to this point, and once again, I'm standing here at what would be simulated as the hatch of the roof. I'm going to take this off. Now, if I'm the person going in, so what I'm going to do is pass this to John, who's going to act as the anchor. Okay, and I'm now the observer. So now I have the belay device. So what I'm going to do is I'm going to feed him some rope, get himself hooked in. So now he's connected. And so what I can do is I can now, this way, I can adjust the rope as he walks around. And what he can do is he needs more. What I can do is just release this like so. But if something were to happen, all I got to do is let go. Just kind of walk that way, John, a little bit. All I got to do, this locks up, and now he's in position, and he's not going to go below waist deep. This is the lifeline in its entirety, really and truly. This is how it works. It can be this simple. If he was in the bin walking around, we would try our best to maintain visual, above all verbal, so that we're talking to each other and that he has what he needs. And if I see anything, then if something goes wrong, he maybe hits a little pocket or something, goes in waist deep. My job then is to call 911, start the rescue procedure, but I do not, under any circumstance, go in the bin after him. Then we got 2 people to deal with, okay? And we also know that this is also breaking the culture of people working alone in grain bins, especially on a farm, because we know of many instances where people have sat there for 3 or 4 hours. Nobody checked on them until it was time for supper. And I personally know of a gentleman in central Illinois here who has been buried in a bin 6 times and survived. So some people still don't get the memo. The point is, if you got to go in safe. Don't go alone. It's the last resort to go in the bin. And above all, have somebody with you and have a system, because this is once again, back to everybody goes home. This is also part of lockout, tag out, and everything else. And even if I'm going in to work on machine guarding, I'm going to be in a lifeline depending on what the situation is. Okay, so that's it in a nutshell.
Do you want to zoom in on the collar and connections?
Oh, up here. Okay, once again, at the top of the bin, you can see. Hold on. We're going to reposition here just a little bit.
This provides ladder protection too, coming down the ladder.
Yes.
Fall protection.
Well, you can look up at the top of the bin. If you can see right there at the roof. Well, that bar might be in there a little bit. But once again, you can see the loop system. This was an engineered anchor that was installed in the roof of the bin. This would also be fall protection if you were coming down the ladder on the inside. Technically, we'd be on the other side, but this is just for demonstration purposes, a whole lot easier to be able to see. But this is how it would work. And John would be inside coming down the ladder, then I would be at the open. We'd be on the opposite side.
And what's your anchor? What's your anchor strength need to be up there?
2 to 1,
2,000.
2,000 at least. Yes. And I know that was a long argument with a lot of folks about determining that. So, but this is the whole system. You know, the most expensive part is probably the rope. Okay. And it's one time, it's not used for anything else other than this. Okay. It's a life safety rope. So it comes out of the bag. We tie the knots at that time. You put it together. It's your rope. It'd be just like your lockout tag out. This could be your rope because your life's depending on it. So with that, we can open up things to question and answer across the board.
All right, we're going to do the Q&A right at the demo spot so we can see you all. A few questions for the panel. Let's go to Paul. A person back to your ladder says, I have several fixed ladders that are between 4 and 6 rungs tall. Do I need to retrofit them to be pass-through ladders?
Sorry, Barb, can you please repeat?
Yes. Says, I have several fixed ladders that are between 4 and 6 rungs tall. Do I need to retrofit them to be pass-through ladders?
See, like that, like this.
Oh,
So you come up straight up and.
okay. So you do have to have that extension beyond your platform, wherever your platform is, you still have to have that 42 inches like we talked about before.
Okay. Dave, has anything been developed for rescue situations to create a high point at the top of the bin?
The bin manufacturers have actually started now in the bigger commercial bins putting anchor points in the bin from the roof. But basically that's about as far as it goes. And then each individual team brings their own equipment to adapt from there. But I don't believe there's anything across the board. And then sometimes we just have to build our own and develop it. Depending on the size or height of the bin, we may use a ladder truck or something of that device. But yeah, there's sometimes we just got to improvise with what we got.
Okay, thank you. And Dave, also, should there always be an anchor at the middle top of the bin, or is a single anchor point on a side entry just as adequate?
No, it's not adequate because it's not going to stop you flowing in the grain. If it's on the side, you're going to flow with the grain, whereas the center is what keeps you vertical, and that's what keeps you from going down. You have to have the side and you have to have the middle. It's the only way for the system to truly hold you in a vertical position. On the sidewall, you're just going to slide down you can't control it. And once the rope did come tight, it's going to help to pull you under. Because if you're not to the top bottom of the dish, it's going to hold you and then you're going to be pulled under even more. Vertical is the key and it has to come from the center.
Great information, Dave, because, as we saw, there were a few of the engulfment entrapments 2020 year that were just that situation. Somebody was on their lifeline and harness, but they still were entrapped.
Yes. Can I, one quick point, wearing your harness, you don't want the harness tight. You want to be able to get your hands between any of the straps. They got to be loose. We've done some studies now with what they call harness suspension, and hanging in a harness much more than 20 minutes. We don't have students in harnesses hanging or suspended more than 20 minutes. So proper fit is critical.
And the difference is because this isn't a personal fall arrest system,
Right.
where personal fall arrest system, that's the concept's different.
Yes.
Okay, thank you. And I do just want to point out to everybody to check out the chat box, because we did have a clarification that OSHA considers lower level and ground level to be the same. And Dave McDonald had posted a link so you could go and look that up. Let me see. Where can people get hands on training for in-bin safety that you were showing us now?
Go
Where
to
can
the
people-
Grain Handling Safety Coalition website, and there's a link to training.
All right, thank you.
And we go just about everywhere.
Okay, and how does one get trapped 6 times in a bin?
Yes,
I think you made that comment.
yes. And he won't buy me a lottery ticket. I'd really like to meet him. So, yes, he has 6 confirmed. He's on a first name basis with the local technical rescue team and this local farm. And this is on a family farm. And just recently, they've doubled their own storage capacity. So, oh joy.
How often is the Lifeline certified, and does it stay permanently in the bin? I have an industrial commercial concrete bin setup, so just trying to find the best way to install the safety equipment.
The clothesline is a permanent installation. The Lifeline that you would go on yourself on a person only goes in the bin when you're going in. But the clothesline is the components of all that is the only thing that's permanent. So
Okay,
the belay device,
Yellow behind you, the lead, that yellow line.
yeah, this is the clothesline system. Okay, this is the pulley system and the top pulley. This is what would be permanently installed in the bin. To be able to pass that rope through to get back to us to make entry. That stays put, but the Lifeline itself and the harness and the other hardware. This part here, this all comes as a package with you. Yeah, there's a bag of rope, and this all can fit right in here. And all go as a unit. Being a rope guy in the rescue world, don't leave knots in the rope. When you're done with it, untie them, because that can bring weakness to the rope. And when we use ropes, we reverse the ends. So every class, we use the opposite end of the rope to do the knot tie. Just a maintenance thing. Don't leave knots long-term.
and also how often should they be certified?
That's record keeping. Anytime a rope, a harness, or anything is used, the ropes and all that, and then follow manufacturer specifications. There's a lot. They've got the best data, but they can tell you what the expectation is. So go with manufacturer's recommendations.
Okay, thank you. You know what, that's through everything you said today, whether it was ladders, your lifelines, everything is about making sure to look at those manufacturer specs. You know, every piece of equipment is built just a little bit differently.
Yes.
Here's one. Can you lower seasonal help into a bin this way to break up clumps?
No.
Okay, he's just kidding.
Not by choice. This would be and not seasonal help. I would be cautious. I would be using my regular people would be the people mostly trained in this. People that aren't around this on a regular basis shouldn't be your people going in the bin.
You know, that's a very good point. You know, and back to the very start of this, your lifelines and talking about the young men that passed away in Mount Carmel, that is exactly what it is, or Mount Carroll.
The interesting part that we made a video after that point, they had their tools secured to lifelines so they didn't lose their shovels and picks, but the people had nothing.
Yeah, yeah.
So bad old deal all the way around.
So a question, as you were talking earlier, the question talked about the lifeline or the clothesline being permanently attached. The question is, won't product flowing into the bin compromise the integrity of the rope that's permanently in the bin?
It's right, it's now it's installed that it wouldn't be directly over the opening, but yes, dust and dirt over time would be something that you would have to probably look at every couple of years or something, probably changing them out.
Okay, yes, and again, it goes back to what you talked about earlier. We always inspect our equipment before.
Yep, it would be a part of your inspection process any other time, so, yeah, just keep track of it, and then, yeah, but yeah, dust, dirt, and grime, that would definitely play a role in it.
All right, if anybody has any other questions, please pop them up into the chat box. Otherwise, I would like to thank you gentlemen today for some great presentations and great demos. You know, they always say we learn a little bit better. We got to hear it and we got to see it. So this has been very effective for us today. Thank you.
And we want to thank Jody and John for being here to help us. Yeah, big time.
Yes, thank you. So thank you all. And the speakers will stay on here for a little bit if anybody has any extra questions, and we can certainly shout them out to everybody. I would like to take this time to thank all of our sponsors one more time. They are the Agriculture Safety and Health Council of America, Bartlett, CoBank, Control Stuff, the Central States Center for Agriculture Safety and Health, and the National Grain and Feed Foundation. And we'd also like to thank our partners. And our partners are those who, in a sense, behind the scenes, were taking care and doing stuff for us. So again, the Central States Center for Agricultural Safety and Health, Central Valley Ag, Eastern Nebraska Research and Extension Center, the Grain Journal, Lamar Advertising Company, and Nebraska Grain and Feed Association, Illinois, University of Illinois, and the UNMC. Thank you all for attending today. Be sure to go out to standupforgrainsafety.org to recognize your participation. And again, all these presentations that you have seen this week will be out on the website at some time here soon.